Alright, in this problem, a ball is initially launched upward with a speed of positive 25 meters per second. That is the initial speed. It's subjected to acceleration in a gravity field, so that is the acceleration, which is g, 9.8 meters per second squared. And then how high will it go? What is the vertical displacement it experiences? I'm just going to call this delta y, because now we're dealing with up and down. So we're dealing with the y-axis. If we were dealing with horizontal, we would call it delta x, but we're not there. The question is, how high will it go before coming to a momentary stop? And if it comes to a stop, its final speed would be 0 meters per second. Using the third equation, we know that v squared, Using the third equation, we know that v squared is equal to v naught squared plus 2 times a times d. That d being the vertical displacement, we'll just leave it as d for a moment. Using algebra, we'll subtract v naught from both sides, and v squared minus v naught squared will be equal to 2 times a times d. Now solving for displacement, we could divide both sides through by 2a. 2's cancel, a's cancel, and the displacement will be v squared minus v naught squared divided by 2 times a, and now it's time to sub answers in. The final speed will be 0, so it's 0 meters per second squared minus the initial speed squared, 25 meters per second squared, divided by 2 times the acceleration, 2 times negative 9.8 meters per second squared. And when we perform 25 squared divided by 2 times 9.8, we'll get an answer that is positive, and that answer will be 31.9, not meters per second, but meters.